let's continue with the chain rule. Last time we learned the chain rule, right? That the derivative of f of g of x equaled f prime of g of x times g prime of x. Okay? So let's take a couple derivatives. So I'll write out the first one here, right? I'll write out that f of x equals e to the x, g of x equals sine of x, f prime of x equals e to the x, g prime of x equals cosine of x. And so dy over dx equals f prime of g of x, yeah, that's right, g of x, times g prime of x. There you go. All right, now for number 2, I'm not going to write out f and g and f prime and g prime. You can and should if it helps you. But see if you can do it. If you're feeling a little bold, see if you can do it without. So here, f prime of x is just what I called it f of x, right? It's going to be f prime of g of x, right? Keep the inside the same, times g prime of x, right? The derivative of the inside, right? And of course, I could rewrite it like this, just stick the g prime of x out front. Right, whoop, and then here we have something a little more complicated, right? G prime of x equals, so here's the chain, right? F of x is x to the 7th, g of x is the inside. Keep the inside the same, times the derivative of the inside. Now, by the way, this whole thing right here is the derivative of this right here. Okay? So then for the second half, we just want to keep that the same. Keep that the same, and then take the derivative of this guy, which looks pretty similar. Okay? So a little gross, a little product rule in a, or a little chain rule in a product rule. But just want to point out that with the chain rule, we can pretty much take the derivative of anything. There are a couple things we don't know how to do. But by and large, any crazy function you come up with, we can take the derivative of. So here's a fun one, right? Take the derivative of this guy. Why don't you do that in class? But think about it, right? Think about it. Okay. So anyway, here's an applied problem, right? We've got this big one. You can pause and read example 2. But once you've got that, so what we have here is that muscle mass is dependent on G, right, which is the amount of IGFs, and then the amount G depends on the amount of protein absorbed. So we're going to assume, let's see one sec, the amount of G of IGFs depends on protein. So what we're going to say, just to be crystal clear, as I'm not sure it's obvious, is we're going to say that G, based on this right here, we're going to say that G of n equals 1/2 times the cube root of n plus 2. Right? So we say, find the rate of change of muscle growth if a person consumes 20 grams of protein before exercising. Okay. Okay. So what we're really saying is find the derivative. I guess what we're really saying is, yeah. I guess what we're really saying is find m prime of n for n equals 20. i.e., find m prime of 20. Now, I might say, well, hold on a second, Dr. Halpern. You didn't give us m of n. You gave me n of g. Yes. So what we have to do is we have to say m of n equals g squared. I'll write it here first. G squared minus the square root of 4g plus 2. But then what we're saying is, well, I guess I'll use yellow again here. G equals this guy. So every time we see a G, we're going to plug in that yellow bit, right? So this is going to be 1/2 times the cube root of n plus 2. Right? And we're squaring that. Okay, and again, get rid of that G. 1/2 times the cube root of n plus 2. Okay? So now we're going to take the derivative of this guy. Okay? And let's see what we get. Now, first off, I guess we can clean this up a little bit. 4 times 1/2 is really going to equal 2. Okay? So m prime of n, using the chain rule, is going to give us 2 times 1/2 cube root of n plus 2, right? Because you see that this is the outer and this is the inner. I'll be right with you. And then we're going to multiply that by the derivative of the inside, okay? So we're going to get, now keep in mind the inner function is this guy. So it's going to be 1/2 times 1/2 square root of n plus 2. And then it'll be times the derivative of n plus 2, which is times 1. Okay? And then it's going to be minus, okay, now again we have to do the derivative of the outside, which is going to be 1/2 square root of, keep the inside the same, that's going to be 2 cube root n plus 2 plus 2 times, oh, you know what, I'm going to need to, this is a little messy here, I'm going to need to really move that over there, times the derivative of the inside, which is 2 times 1/2 square root of n plus 2. The plus 2 is going to go away. I guess these guys cancel. So I guess we're left with this lovely equation. I guess we also have certain things cancel out, right, like that and that. But yeah, that's our derivative. And then we would plug in n equals 20. And I will leave that to you.